In this video, I will talk about the basic introduction to electromagnetic radiation. We will learn what is electromagnetic radiation and wave descriptors, and discuss types of waves with the spectral ranges and application in everyday life, as well as in chemistry. So, what is electromagnetic radiation? Electromagnetic radiation is the waves in electric and magnetic field propagating, which means radiating, through space. So here is the electric field in blue in y direction, and here is the magnetic field in red in z direction. They are orthogonal each other and oscillate in phase. In this case, electromagnetic wave is direction in positive x direction. Now let's learn some terminologies. If there is a wave, this is amplitude, the maximum magnitude of displacement, and the distance between successive wave peaks is the wavelength. Basically, it represents one cycle. And the time required for an entire cycle is period, and frequency is the number of waves that passes at some point per unit time. So in the rest of session, we will talk about wavelength and frequency a lot. Wavelength is written in lambda and unit is meter, and frequency is written in nu and unit is hertz, is 1/second. So from this information, we can also calculate speed of wave. So frequency times wavelength will be speed of the wave. It gives unit from meter per second. So now we know basic terms of waves, so let's talk about the spectral ranges of electromagnetic radiation with respect to wavelength and frequency. From 10 to 6 to 10 meter is radio wave, and around millimeter is microwave, and around micrometer will be IR. And from 350 to 800 will be visible, is from red to purple like a rainbow. And around few nanometer will be ultraviolet, and X-ray and gamma ray in order will be around picometer. You can see approximate scale of wavelength here and frequency here, but be careful here because energy and wavelength scale. In this direction is increasing wavelength, and in this direction is increasing energy. We can see this relationship in this equation, Planck equation. So energy is equal to Planck constant times frequency, and as I mentioned earlier, speed of wave is equal to frequency times wavelength. So it can be expressed energy is equal to Planck constant times speed over wavelength. So as increasing in energy, it will be shorter in wavelength. So if we see the diagram again, radio wave is small in energy and larger in wavelength, and gamma ray is large in energy and short in wavelength. Then, what kind of application are there for each wave types? First, in everyday life, radio wave is everywhere near us. Television, GPS, phone, wireless network, radio, and microwave we can see micro oven to heat the food. Micro oven is targeting water molecule. After we use microwave oven, we can see that it is hot but also dry because it's targeting water molecule. And in IR, we usually do thermal imaging, and visible is basically vision. So you can see rainbow in nature. And UV light, you can think about the sun. From sun, we get burned, so we need to put sunscreen to protect ourselves from UV light. But we do need to get sunlight since it produces vitamin D in our body. And X-ray is used to image a picture inside of our body. In a hospital, we take X-ray images to check whether our bone is broken or not. And then last, gamma ray is used to treat cancer cells by damaging them in the healthcare. Okay, then what about electromagnetic radiation application in chemistry? In radio wave frequency, there is NMR, nuclear magnetic resonance spectroscopy. This is to promote transition between nuclear spin energy levels. And microwave, there is rotational, IR, vibrational spectroscopy, and UV-Vis, there is UV-Vis absorption and also fluorescence spectroscopy. And in X-ray, there is X-ray absorption spectroscopy and X-ray emission spectroscopy. These are inner shell spectroscopies for core electron, not for the valence electron. And in gamma ray, there is EPR, is electron paramagnetic resonance spectroscopy. It is used to study chemicals with unpaired electrons. I hope this video gave you a good introduction to the light, electromagnetic radiation. Next video, I will talk about the wave-particle duality of light. Thank you.